Hi there. This is going to be a little video. Well, it may be a long video, but I'm not sure. I've decided I need to make some more tea mats for the Taig mill, and so I'm making half a dozen of them out of a round bar that I had, mild steel bar that I had in the scrap box. So I'm taking a 25 thou cut with a single insert Chinese index insert boring bar, I guess you could call it. So you'll see how it goes. Fine milling. Running at 3400 RPM. I'm using a little drop of A1 cutting oil. Tuning the height down to 0.480 on the total height from the bottom to the top of the peanut. Little dropper. That's at almost 30,000 steps to cut. with that depth of cut, there is absolutely no effort whatsoever on the lead screw in climb milling. When it's climb milling, the handle is just gripped lightly in my hand, and I'm just turning it, and it's almost feeding itself in, which is climb milling anyway. So yeah, there's no stress or anything on the machine really, other than the fact that it's a small machine and it's taken a fairly hefty cut for this size of machine. So all in all, it's doing a pretty good job. So I've moved it over to 350, and I'll show you I've fitted a digital readout on the y-axis because I got quite a bit of, I got approximately 6 thou backlash on the lead screw on the y-axis, and so I was finding that it was difficult to recalibrate every time I moved the y-axis. So I decided to put a digital readout on there, an EasyView DRO from iGaging, and I'm very happy with it so far. I only just recently put it on, but it seems to be doing a good job. And what I'll do is I'll move the camera over after I've done this pass, because you don't want to keep on seeing this, just this going. And I'll move the camera over and I'll show you the setup that I did with the y-axis readout. Okay. That off. Okay, I'll see if I can zoom in and show you the cutter that I'm using on the z-axis. Where's my where's my brush? What's happened to that? Oh, here it is. There we go. That's the, okay, that's the, what's his name? And I'll see if I can zoom in a bit and give you a better view. There we are, you can see that. That's just a single, I hope it's in focus. Maybe I should go out a little bit. Maybe that's a bit better. Yeah, you can see the insert that I have there. And I like this insert better because with this type of cutter that I was first using here, I'll zoom out. I'll zoom out. See if that's better. Yeah, this type of M-mill single insert I was using originally, and I didn't like it because it seemed to me to tend to rub on the whole complete bottom surface of the cutting insert there, right at the bottom there. It seemed as though it was cutting at 90 degrees to the axis and to the vertical, and it seemed like it was getting a lot of rubbing taking place. And so with this type of insert, the bottom surface, the bottom cutting edge is at a slight angle. So in other words, it's just really the tip of the insert that is making contact with the metal in a sense, but there's no rubbing taking place because the bottom is at 90 to the vertical. So that's why I converted over to one of these with this type of insert. So I just thought I'd mention that. Okay, I'll see if I can get over to the other side and give you a rough, let's see. Okay, where are we? See if I can get down there. Where are we? Ah, there we are. Yes, okay. I bought this a 6-inch scale, and what I did was the reader, or the slider, the reader I think it is called, that slides backwards and forwards. I attached that to the T-slot that is in the side of the Y-axis table, and use that for location of the reader itself. And what I did was I decided that I was going to make a bracket, which you can you see that down there? Down there, yeah, just there, just there, a right angle bracket I made. And what I did was I bored out a 1/2-inch hole for a small 1/2-inch ball bearing, and set that in the 1/2-inch hole, and I've used that as a pivot point for this end of the scale. And you'll see that at the other end back there is no support whatsoever. So what I did was I set the reader up on the T-slot first of all, and then I kept moving in the Y-axis table until I got a reading on here with the dial indicator on this top surface here. When I moved it from this end to that end, to the reader, there was no movement taking place there. It stayed on 0, which then indicated to me that this was parallel. This scale was then parallel with the travel of the ways on the Y-axis. And so if there was any discrimination of the slightest, if this was fixed and everything was perfect, then it would work fine. But because I'm coming off of this table, I didn't like the idea of I would sooner have come off the machine there somewhere, but there's no machine surfaces really that I could have come off that would have given this this scale the right position, and I was worried about stress between the reader moving along the scale and any pressure being applied to the scale. So I've left this end in mid-air, in the airspace, and so it's only connected at this end, and it seems to be working out. I did the same thing with the where are we, the Z-axis scale that I set up there, and that's the same thing, except that it's on a metal bracket up the top here, but there is movement if necessary, if there's any discrepancy between this reader being positioned at a set point and not being able to move laterally, then there wouldn't be any pressure on here, because this would just float. This is like floating. It's like a floating blade, and it's the reader that's actually aligning everything. So that's what I did there. So I haven't set up the unit yet, the readout. I've got it there at the moment. There it is. There, it's an EasyView-DRO, just a cheap thing. I'm going to eventually set it up here on the upper column, on the vertical column of the mill eventually. So that's another job that I'm going to do. But I thought I'd get these T-nuts done first. Okay. Thanks for watching.